So first we need to analyze this object. Okay? This radius is 0.2 meter, and a light toward this object 0.5 kilogram. We release from the rest of the object the acceleration, we know, 5 meters per second square. That's what we know. So first we need to analyze here. Okay. There is a gravity. There is a tension from the cord. And the gravity minus the tension will give the acceleration for this, right? Because we know the acceleration is 5 meters per second square. Okay, so that's the first one we got. And then from here, on this wheel, we know there is a force also equal to this T, right? The tension is T. Tangent to this wheel. Remember the formula? How do you call this?
Torque.
Torque.
Yeah.
So torque is equal to the moment of inertia times the angular acceleration, right? So basically we have, and also we know here on the wheel, the tangent acceleration is equal to this acceleration 5 meters per second square, right? The tangent.
Okay.
So at this point, it's also, but this is equal to R times the angular acceleration. And so the question is, asking you what is this? What is this moment of inertia, right? So let me see. What is this? This is T times the R, right? The force times the radius. So that is torque is equal to the moment of inertia times the angular acceleration, which is
A over R.
over R, exactly.
Right.
So that's the key for this question. So from that, what we got is the inertia equal to tangent times R. Move this over here. T R square. So we got this. Right? If you put all the number, we know T, you know how to calculate T, is mg minus ma, and it's mg minus a. We know g is 9.8, right? And a is 5 from here. So that would be 4.8 times m is 0.5. so you got 2.4 Newton. It's the T. We know the T. And the R is 0.2 meter. And so it's 2.4 times 0.2 square over AT is 5. Right, its acceleration is 5. So if you calculate these, you got 0.019. So it's D, the answer. So there are several important. So first you analyze the force, and then you need to know this formula and this formula. With these three, you got this. And then you just plug in the number. You got the answer. Okay? So for this type of question, we need to use the same formulas. For number 6, the same. The radius is 0.25 meter, and the moment of inertia of the wheel is 0.04 kilogram meter square. And then here is 0.5 kilogram, and then it's released. What's the acceleration? That's the question. Okay? So still use the same. Actually, that's equal to, in linear moment, is equal to F equal to ma, right? So it's a similar formula in linear. But here you need to think it's angular, circular movement. And then from this, we know here there is a tension. Torque is tension times the R. Moment of inertia, we have it here. It's 0.04, right? The angular acceleration is the tangent acceleration over R. So from this, we got this. Okay, and then if you analyze, here is mg, here is t, and we know mg, the same formula, is equal to ma, because we know the acceleration is a, right? So we'll get this t. P is mg minus ma times r is equal to a over r, right? And then we know r is 0.25. R is 0.25 and m is 0.5. So if we plug in the numbers, okay, we'll get 0.5, G is 9.8 minus 0.5, we don't know what is A, times 25 equal to times 8 over 0.25. So if you calculate and simplify this, you get 0.306 minus 0.031 A is equal to 0.04 A. And then you will get 25 A. So you can use your calculator to calculate to see if you can get the same number.